If you could pull back from our galaxy, past our neighbors, past billions of other galaxies, and see the entire observable universe at once, what would you expect to see? A random splash of light against the dark? A beautiful but chaotic scattering of stars and galaxies? For a long time, that's what we thought. But we were wrong. The universe isn't random at all. On the very largest scales, it has a structure, a breathtaking, magnificent, and utterly surprising pattern. It's an enormous, glowing network that stretches for billions of light years in every direction. We call it the cosmic web. This isn't just a metaphor, it is the physical architecture of our cosmos. This web is made of two main parts. The bright glowing threads are called filaments. Imagine immense rivers of galaxies, gas, and dark matter flowing through space, stretching for hundreds of millions of light years. These filaments are the superhighways of the universe, connecting everything together. And between these glowing threads, almost nothing. These are the voids. They are colossal, nearly empty bubbles of space, so unfathomably vast that our entire Milky Way galaxy would be like a single grain of sand lost inside one. The voids are where the universe is quiet, dark, and profoundly empty. So, what built this incredible structure? The architect is something we cannot see. The galaxies and gas that light up the filaments are just the decorations. The real structure, the scaffolding that holds it all up, is made of a mysterious, invisible substance called dark matter. Think of it like this. The cosmic web is a colossal, invisible tree, and the galaxies we see are just the twinkling lights on its branches. 5 times more abundant than all the normal matter we know. Dark matter is the silent, unseen force that has been shaping the universe since the very beginning. To understand how it was built, we have to go back in time, all the way back to just after the Big Bang, around 13.8 billion years ago. The universe then was nothing like it is today. It was an incredibly hot, dense, and unbelievably smooth soup of particles and energy, expanding everywhere. The key word is almost. It wasn't perfectly smooth. Woven into this cosmic soup were tiny microscopic fluctuations, ripples from the quantum world itself. These were incredibly small differences in density. Some spots were just a fraction of a percent denser than the areas around them. These tiny jitters might seem insignificant, but they were everything. They were the seeds of all future structure. The slightly denser regions were the blueprints for the filaments and great clusters of galaxies. The slightly less dense regions were destined to become the immense, empty voids. And then, a familiar force began its slow, patient work. Gravity. In that early, smooth universe, gravity began to pull on those tiny, dense spots. But it had a special relationship with dark matter. Because dark matter doesn't feel pressure from light or heat, it could start clumping together immediately, undisturbed. Gravity began to gather these invisible particles, starting a process that would unfold over billions of years. For hundreds of thousands of years, the universe was a tale of two parts. An invisible skeleton of dark matter and a smooth, evenly spread fog of normal matter. This normal matter, the stuff of you and me, was pushed around by the intense light of the early cosmos, unable to clump together. But as the universe expanded and cooled, a crucial change happened. Light particles no longer had enough energy to shove atoms around. Suddenly, normal matter was free to feel the gentle, persistent pull of gravity from the dark matter structures that had been growing in the dark. Imagine a fine mist slowly settling onto an invisible spider's web. That's what happened. Vast clouds of hydrogen and helium gas, the first elements, began to drift and fall, drawn towards the densest parts of the dark matter filaments. This was not a fast or violent process. It was a slow, cosmic gathering that took millions of years. The gas flowed in great rivers from the empty voids, collecting along the dark matter highways. The universe was still dark to our eyes, but it was no longer smooth. It was gathering, concentrating, preparing for its first magnificent act of creation. The stage was set, and the main ingredient for stars and galaxies was now in place. And then, the universe lit up. As more and more gas piled up in the densest knots of the filaments, gravity's power became immense. The gas clouds collapsed under their own weight, squeezing their cores until they became unbelievably hot and dense. so hot that the very atoms of hydrogen began to fuse together, releasing a tremendous burst of energy and light. The first stars were born. For the first time since the Big Bang's initial afterglow faded, there was new light in the cosmos. These first stars were giants, hundreds of times more massive than our Sun, and they burned with a brilliant blue-white intensity. They were the lights being strung along the invisible cosmic skeleton, revealing its grand structure. The dark web was now a glowing web, a celestial filigree stretching across the sky. Now, and look at the grand architecture of this web. The long, thin strands where galaxies form are the filaments. They are like the great interstellar highways of the universe. But what happens where these highways cross? What do you find at the intersections? You find the cosmic cities. These intersections are called nodes, and they are the most massive, most dense, and most gravitationally powerful places in the entire universe. Here, the gravitational pull is so strong that matter has piled up over billions of years, forming colossal structures known as galaxy clusters. Think of a cluster not just as a group of galaxies, but as a cosmic metropolis. A single one can contain thousands of galaxies, all orbiting a common center of gravity. They are filled with a superheated gas that glows in X-ray light, and of course, an enormous amount of the invisible dark matter that holds the whole city together. These are the downtown centers of the cosmos. And here is something truly amazing. This structure is not frozen in time. The cosmic web is alive with motion. The galaxies within the filaments are not just sitting there. They are flowing. They are moving along these cosmic highways, like a steady stream of traffic, all heading towards the great clusters at the nodes. This is cosmic gravity in action on the grandest scale. Everything is being pulled towards the most massive regions. The filaments feed the clusters, delivering a constant supply of new gas and new galaxies. This means the great cosmic cities are still growing, still assembling, even today, 13.8 billion years after the beginning. The universe is not a finished painting. It is a masterpiece still in the process of being created. We can see this flow, this cosmic traffic, by carefully studying the light from millions of galaxies. A tiny shift in the color of that light tells us if a galaxy is moving towards us or away from us, and how fast it's going. When we put all of those measurements together on a map, the secret structure of the universe snaps into focus. We see the great cosmic rivers and the quiet, empty voids they flow around. And now, for what might be the single most mind-expanding idea in all of science. Where did this unimaginably vast pattern come from? The answer is not found by looking at bigger and bigger things. The answer, amazingly, comes from the smallest possible thing you can imagine. The blueprint for the entire cosmic web was written in the first flicker of time. In the first tiny fraction of a second after the Big Bang, the universe was a hot, smooth soup of energy. But at the tiniest subatomic level, the quantum level, it wasn't perfectly smooth. There were constant, random, microscopic jitters, tiny, fleeting ripples in density. Then, a process we call cosmic inflation kicked in, and the universe expanded faster than the speed of light, stretching those infinitesimal quantum jitters into structures of astronomical size. Just let that sink in. The largest structure known to exist, this web of galaxies stretching across billions of light years, is a direct, magnified fossil of the quantum world from the dawn of creation. Every massive galaxy cluster, every great empty void, is a frozen echo of a random flicker that existed when the universe was less than a second old. The universe is its own magnificent time machine and microscope, and this isn't some faraway story that has nothing to do with us. We are living inside of it, right now. Our home, the Milky Way galaxy, is not a lonely island adrift in an endless sea. We are a citizen of this cosmic web. We live inside one of its long, shimmering filaments. Our specific cosmic address is on the outskirts of a busy galactic neighborhood called the Virgo cluster. This cluster, and our own local group of galaxies, are all part of an even grander structure, a supercluster we call Laniakea, a name that means immeasurable heaven. And we aren't stationary. Our entire supercluster is flowing along this filament, pulled by gravity toward an even more massive region we can't fully see. Yet, even as gravity patiently weaves this cosmic tapestry, a mysterious and invisible force is working to pull it apart. We call this force dark energy. It seems to be a property of space itself, an anti-gravity that is causing the expansion of the universe to accelerate, pushing all the galaxies away from each other faster and faster. This leaves us standing before the greatest cosmic mysteries. What exactly is this dark energy? Is its relentless push destined to one day overcome gravity's pull? Will it stretch the beautiful filaments of the cosmic web until they tear, isolating every galaxy in its own lonely bubble of expanding space? The ultimate fate of the universe is a story whose ending we do not yet know. So the next time you stand under a clear, dark sky and look up at the stars, I hope you see something entirely new. You are not seeing random points of light scattered against a black background. You are looking out from your window inside a glowing, interconnected cosmic city. Every star, every faint smudge of a distant galaxy, is a neighbor in our small corner of this immense structure. We are a part of the web, looking out at other parts of the web. The night sky is not a picture of emptiness. It is a view of home. But how do we see something so faint and so enormous? We can't just point a telescope and take a picture of the entire web. It's mostly made of dark matter, which is invisible, and very thin hydrogen gas that doesn't shine on its own. The secret is to use light from something else, something incredibly bright, as a kind of cosmic flashlight. We use the light from quasars. A quasar is a fantastically luminous object at the center of a very distant young galaxy. They are powered by supermassive black holes feeding on enormous amounts of gas and dust, and they outshine everything around them. This light travels across the universe for billions of years to reach us. And on that long journey, the light passes right through the cosmic web. It travels through the empty voids and, crucially, through the gassy filaments. As the light goes through a filament, the hydrogen gas inside it absorbs very specific, tiny slivers of that light, leaving a unique fingerprint behind. By looking at a quasar's light when it reaches us, we can see which parts are missing. Those missing pieces are like a barcode that tells us exactly how much gas the light passed through and where it was. It's like detecting a spider web, not by seeing the web itself, but by seeing the morning dew caught on its threads. We are mapping a shadow to see the invisible structure, and this technique reveals the staggering emptiness of the places between the filaments, the great cosmic voids. These are the largest, most desolate regions of the universe. They are immense bubbles of near-nothingness, where the expansion of the universe has triumphed completely over gravity. They are not perfectly empty. A few stray, lonely galaxies might drift through them. But compared to the filaments, they are profoundly underdense. Gravity, over billions of years, has acted like a cosmic shepherd, herding matter out of these regions and into the filaments and clusters, leaving these vast expanses behind. To feel the scale of a void, imagine the distance from our Milky Way galaxy to our nearest large neighbor, the Andromeda galaxy. That's about 2.5 million light-years. The largest voids are hundreds of millions of light-years across. They are spaces so vast that light itself takes longer than the age of the dinosaurs to cross from one side to the other. And this incredible structure, this web of everything, is not finished. It is still evolving right now. The universe is caught in a cosmic competition between two powerful forces. Gravity is still pulling matter together, making the filaments denser and the galaxy clusters at the nodes even more massive. But at the same time, a mysterious force we call dark energy is causing space itself to expand, faster and faster. This expansion is stretching the entire web, pulling the filaments apart from each other. It's a battle between gravity's pull and dark energy's push. In the very distant future, dark energy might win. The expansion could stretch the filaments so much that they break apart. The great superclusters of galaxies, the nodes of the web, could become completely isolated islands in an ever-widening, dark and empty sea. Each one, a self-contained universe, forever cut off from the others, unaware that the grand cosmic web ever existed at all.